At T equals 0, biscuits with temperature 100 degrees Celsius are moved from the oven. And the temperature of the biscuits is modeled by the differential function b, where the derivative of b is equal to this exponential decay equation. We're being asked how much cooler are the biscuits than the T at T equals 10. Well, at T equals 10, the temperature of the T, or H of 10, from the table, if we just take a look at the table, it's going to be 43 degrees Celsius. Okay, so that's one thing. We've been given the derivative and we need to find the b. Well, to do that, we need to integrate the derivative function and we need to have initial condition. And here we have our initial condition. Our initial condition is at T equals 0, the temperature is 100 degrees Celsius. So if I want to come up with my equation for b, my equation for b is going to look like this. B as a function of T is equal to, I need to start at 100 degrees Celsius, and then I'm going to add the change in B, which is going to be determined by the area underneath that curve. So it's going to be equal to 100 plus the integral from T equals 0. Okay, and again, I want to make sure I highlight that. This is my initial condition as 100 degrees at T equals 0. So that's my starting point. All the way to x. Oh, sorry, I'm going to make that into t. All the way to some time t of b prime. I'm just going to change this variable to x d times dx. And then I'm going to replace that b prime with that expression. So now it's going to look like this. This is now my function b that calculates the temperature of the biscuits. And it's going to be negative 13.84 e to the negative 0.173 t, or sorry, x, let's make that x, times dx. Okay. So then I need to put that into my calculator and I need to find the area under the curve. So this is my b of t function. Okay, so if I want to find the b at time equals 10, it's going to be 100 plus the area under the curve from 0 to 10 of this function. Okay, so I'm just going to find the area under that function. I'm going to graph that expression. Okay, and then so using my integral, so I'm going to end up with b of 10 is equal to 100 plus the area under that curve. So from 0 to 10, I'm going to integrate this. And my temperature has decreased by 65.817. So I'm going to just round that to 82. Okay, and then so I end up with the temperature now becomes 34.18 degrees Celsius. So that's the temperature of the biscuits. So how much cooler are the biscuits than the tea? Well, the difference in the temperature is going to be 43 degrees minus 34.18. Okay, so 43 minus 34.18 gives us they are cooler by 8.82 degrees Celsius. Okay, so this is my temperature differential.